Video 53. Mathematical induction. So there are different ways to prove a particular result. One of the ways is using mathematical induction, which we can use that the validity of the result for a positive integer only. So in this section we are going to see mathematical induction for n greater than or equal to 0 or for n greater than or equal to 1, where n is an integer. So we start with the principle. What is the principle of mathematical induction? Principle of induction. Let P of n be a given statement. For n is an integer, and n greater than or equal to 0 or n greater than or equal to 1. Then P of n is true. P of n is true if condition 1, what is known as basic step. Basic step if P of 0 or P of 1 is true according as n greater than or equal to 0 or n greater than or equal to 1. The basic step should be true. Second condition is induction step. P of k plus 1 is true whenever P of k is true. So when these two conditions are satisfied, then P of n is true for any integer positive. N is an integer, non-negative integer, we can say. So there are three types of problems in principle of induction. Problems on type 1. So mostly series, summation of series. Prove by induction that 1 plus 2 plus 2 squared plus etc. plus 2 power n equal to 2 power n plus 1 minus 1. N value greater than or equal to 0. So proof. Let P of n be the statement 1 plus 2 plus 2 squared plus etc. plus 2 power n is equal to 2 power n plus 1 minus 1. This is our statement n. Then P naught is the statement. Look, there are n plus 1 terms on the left hand side, because this is starting from 1, which is 2 power 0. 0 to n means there are n plus 1 terms. In P of 0 there will be only one term, this term alone. On the right hand side we will be getting 2 power n is 0 plus 1 is 1 minus 1. P of 0. P of k means 1 plus 2 plus 2 squared plus etc. plus 2 power k. N is replaced with k equal to 2 power k minus 1 equal to 2 power k minus 1. And P of k plus 1 is 1 plus 2 squared plus etc. 2 power k plus 1 ending with 2 power k plus 1. Right hand side is 2 power k plus 1. These three steps are very important. Whatever the series summation you want to prove, take that series as P of n. Then find what is P of 0, P of k plus 1. P of k is very simple, replace n by k on both sides. P of k plus 1 replace n by k plus 1. These terms n by k plus 1 right hand side. So P of k will be on the right hand side. If you put n is equal to k, you will get k plus 1. Here k plus 1 means you will get k plus 2. Now we have to prove the basic step. What is the basic step? We have to prove P of 0 is true. LHS of P of 0. LHS is 1. RHS of P of 0 is equal to 2 power 1 minus 1, which is also 1. So this implies LHS of P of 0 equal to RHS of P of 0. Therefore, P of 0 is true. That is the basic step. P of 0 is true. Now we will have to assume induction step. Induction step. Assume that P of k is true. That is, P of k is true means 1 plus 2 squared plus etc. plus 2 power k is equal to 2 power k plus 1 minus 1, equation number 1. So this is true. That is equal to 2 power k minus 1. Now using this, we will have to prove P of k plus 1 is also true. What is LHS of P of k plus 1? LHS of P of k plus 1 is 1 plus 2 squared plus etc. up to 2 power k plus 1. This is 1 plus 2 squared plus etc. plus the term before 2 power k plus 1 is 2 power k plus 1. And this bracket value is given in 1. So the summation 1 to 2 power k is 2 power k plus 1 minus 1 bracket value plus this term 2 power k plus 1. This is 1 2 power k plus 1. This is another 2 power k plus 1. X plus x is 2x. 2 into 2 power k plus 1 minus 1. This power is 1. So this is equal to 2 power 1 plus k plus 1 is k plus 2 minus 1 equal to RHS of P of k plus 1. Therefore, the conclusion is P of k is true. Therefore, P of k plus 1 is true if P of k plus 1 is true if P of k is true. That is, whenever it is true for k, it is true for the next integer k plus 1. P of 0 is true. Say this is 2. P of 0 is true. Therefore, by 2, the next integer to 0, P of 0 plus 1, P of 1 is true. Now, P of 1 is true. Therefore, by 2, the next integer P of 2 is true. Continue like this, etc. P of n is true for any integer n greater than or equal to 0. So this completes problem number 1.